Now, this is a little spoiler alert. Once we're finished with our V3 release, which is upcoming in the next 2 to 3 weeks, we're gonna open source this one as well. So in the end, you will definitely be able just to say, show me all the IP-NFTs of this address. Show me all the IP-NFTs of the currently logged in user. Show me the history of those. Ungate the content, please. Here's an auth stick or something. This is what you will be able to do using Molecule's SDK without really having to worry that much about Web3 technology.
Welcome to the DeSci Podcast. In this episode, we'll explore the technology behind the IP-NFT and its potential for revolutionizing scientific data collection, storage, and sharing. This episode is meant for our technical audience, or those curious about the technology behind the IP-NFT. If you are non-technical but working in DeSci, feel free to share this episode with the developers who are helping you to build. Our special guests, Stefan Adolf, Senior Web3 Engineer at Molecule, and Benji Leibowitz, former biotech VC and now Product Manager at Molecule, discuss the IP-NFTs modularity, fractionalization, metadata storage, token standards, content gating, wallets, user experience, and more. They will also talk about how developers can build using the IP-NFT and how they can contribute to open source infrastructure at Molecule. We hope you enjoyed today's episode. Stefan, Benji, welcome to the show. Great to have you on. For those of you who don't know, Stefan and Benji and I are colleagues working here in Berlin, and Benji's in Chicago. Let's maybe kick it off with you guys telling us and the audience, what is the IP-NFT and maybe who should use it, and why should a developer or a DeSci builder care?
Cool. So my name is Benji. I'm a product manager at Molecule. I joined in September. It's been an awesome ride so far. And the IP-NFT is a mechanism for people to take legal rights in the real world and put them on chain so that, rather than a person holding those rights, have a wallet that holds those rights, or maybe a set of wallets. So what becomes very cool about using our protocol is you can basically fundraise and have donations toward a project that has rights in the real world. We think this is very
before you continue.
Really
what's with the hoodie and the sunglasses? It's like a little bit distracting, to be honest. for those who are listening on the like Spotify and wherever there's not video or not on YouTube, Stefan and Benji are wearing hoodies with the caps on and with sunglasses.
We're actually trying to win the lookalike contest here, because this is how we all look at Molecule, Heinrich. Unfortunately, you're a little exception here, but we told you have to wear sunglasses tonight.
I forgot mine at home. I'm so sorry, but next time. Yeah, Stefan, if you maybe want to also introduce yourself to the audience, go ahead.
Absolutely. So my name is Stefan Adolf. I'm actually a native Berliner. I joined Molecule in October. I'm a software developer for the last 20 years, so I'm one of the older ones here. But I think I bring along quite a lot of experience. I'm one of the core coders behind the IP-NFT protocol. I'm building lots of front-end stuff in Molecule, and have been working the last 3 years deeply in Web3 and the EVM ecosystem, so building smart contracts, NFT collection, all that stuff. Actually, also have been one of the finalists of ETH Online 21 with an NFT protocol called Splice. And I'm very happy to be on this podcast and brag a little bit about the technical backgrounds of IP-NFTs, because I think this is what many developers out there, particularly, and maybe even DAO developers, are pretty curious about, right? So how is that working under the hood, and why is it maybe from some perspective quite complex, and why isn't it for others?
Cool. And we can get into why a developer would care or like to build on this, but let's maybe start with speaking a little bit about the potential advantages you looked at when choosing between ERC 721, 1155, 3525 for base primitives.
Sure. So I think the last one you mentioned is the one that's most exciting, and we are not using it, but I definitely want to mention that. It's called 3525 Semi-Fungible Token Standard. It's rather new. It's actually a final standard as an ERC. And we started looking into it when our friends over at Protocol Labs were considering using those for hypercerts. And it's actually a standard that allows you to fractionalize ERC 721 tokens. Not really fractionalizing them, actually. It's more like uploading value to ERC 721 tokens. And this is why we thought in the first place, like last October, November, that it might be a good idea to use this kind of blockchain primitive to model IP-NFTs. But then we actually thought, we actually evaluated the gas costs coming along if you really fractionalize using ERC 3525, and we noticed that gas costs during fractionalization events might be very high if you fractionalize them a lot. And this is why we actually rolled back to ERC 1155, as hypercerts did as well. So hypercerts also at the same time rolled back their code base to ERC 1155, the multi-token standard, which is pretty well known in the NFT space. It's pretty gas efficient. It allows you to fractionalize, not really fractionalize, but to create more tokens of one token kind, which was our first idea of how we could fractionalize IP-NFTs. So no secret told, but we are actually not using ERC 1155 to really fractionalize something. We're only using this as our base standard to make IP-NFTs possible. It has definitely more security features than ERC 721. And it got quite a lot of extensions that make it suitable to act on transfer events, for example. And this is why we, in the end, chose that standard for our IP-NFT stuff. We could actually also have chosen ERC 721, the very plain one. But now it is like it is, and there are not really many trade-offs. There are actually more. There's more potential when you have 55 at hand, because you can come up with pretty weird ideas of, I don't know, issuing an IP-NFT several times. I don't exactly know if this really makes sense, but if it would make sense, we are prepared to use that one, actually.
Yeah, Stefan, I think if I remember correctly, you did a direct gas analysis, and I think what you found was, I think there was a 4 to 5x gas cost associated with 3525 over 1155, and I think that was kind of the nail in the coffin for 3525 for us.
Yeah, it's also about the usability, right? Because no wallet out there or no standard software would actually support the display of 3525 values. The nice thing about 3525, for everybody who's maybe curious and wants to look that up, I can tell you what's really great about that standard is that at its core it's behaving like an ERC 721. So this is like a standard NFT, but as I said, it's like a purse NFT. So it can contain value, and that value is not denominated in any sense. So it's just some number on it. And you can transfer values between NFTs, which is super cool, but it's not exactly matching our use case, right? And this is why we more or less decided to dismiss it. From a gas perspective, yes, exactly. So if you would like, so everybody who would like to have a fraction in his wallet of this IP-NFT, and we would have used 3525, and let's say we might have fractionalized towards 1,000 users or so, the gas prices are minting 1,000 ERC 721 tokens. And this is hilariously expensive, right? And this is why we, in the end, came up with, okay, guys, we cannot do that. Let's just do it differently.
Awesome. And for those who were around in just before Christmas last year, we launched the IP-NFT V2. And yeah, I was wondering if you guys can maybe touch on what are the prerequisites and why did you decide to go with mint passes and reservations for V2?
As for mint pass and reservations, I think what we were thinking there was, we're releasing this in kind of like a closed beta. We're looking for feedback from users. We're trying to understand how people are actually using the protocol. And so the best way to do that is have some slight control over who's actually using it, just to make sure that you have some sort of like mode of communication to them. We really value user feedback. And so if you release this kind of open source protocol and kind of let anyone use it, then you have no way to get that feedback and understand how are things meeting people's needs, how are they not. Of course, we have our Discord, which, we want people to drop into, but just making sure that we have some sort of line of communication to the people using it was super important to us. And then another thing is, the NFTs that are created from the protocol persist on chain forever. And so we just wanted to make sure that, nothing inappropriate or spammy was used for it. But yes, I think the long-term goal is to remove, all sort of friction and permission required to use the protocol and completely make it permissionless.
Precisely. So you must imagine the metadata of IP-NFT is brought along by the minter, so they can bring along whatever they want. Actually, you cannot validate that on chain, right? So you have to trust the one who is minting an IP-NFT that the metadata is correct. And I cannot. If you want this to have more or less permissionless, you have to ensure that people are not uploading anything that's not valid. And I cannot really validate that in a permissionless system. But what I can do, I can gate the access to the mint method and tell them, okay, before you just hit the mint button, maybe it's a good idea to call us first. At least read the documentation and get that mint pass. So you have at least proven that you at least have read the docs, right? So otherwise you wouldn't have got the mint pass in the first place. This is our little gating to avoid spam or useless stuff on the protocol. It's a little bit hard to shut it off, as I said, because you cannot really validate the metadata that people bring along on chain. So we have to trust our minters a little bit. But it's rather simple to obtain a mint pass. You just drop a line on our forum, and we're issuing one free for you.
At the moment, who's the ideal user for the mint pass? Like, who would you give a mint pass to?
I think one of the coolest parts about just being having an open source protocol is people come and use it that you would never have expected to. And so, we have some people that are building similar protocols for different applications. So, whereas, our primary use case is doing patents and patent licenses for pharmaceutical products, we had someone come through and they're currently, we're messaging them. They are trying to tokenize copyrights associated with media and video and music. And so, it's very analogous and similar to our use case, our implementation, but a completely different use case. So I thought that was super interesting. So, we have our biases as to who we want the protocol. We want scientists and researchers who want to fund research and tokenize those rights to use the protocol. That being said, there are completely different applications and users that, we never would have guessed, but it's awesome to get their feedback, just to learn from them as well, and see kind of the convergent evolution that so many different protocols are forming, because, everyone's kind of thinking the same way.
Yeah, it's fascinating. It's exciting that people are wanting to use it beyond just biotech. So, excited to see where that's going. Maybe moving on to storage and IP-NFT metadata. Where is the metadata stored, and how is the metadata structured?
That's actually, particularly for developers, the most pressing question, right? So, where is the value coming from, and how does an IP-NFT become an IP-NFT? And honestly, it becomes an IP-NFT by following a certain metadata structure that's actually open sourced. The code itself isn't open source yet, but the complete documentation is to be found on the molecule docs, so you can see the whole schema, how an IP-NFT metadata should be crafted on our documentation page. And this is exactly where the IP-NFT becomes unique. So metadata, IP-NFT metadata contains links to legal documents, to the research agreement or joint developer agreement and the assignment agreement that are actually defining the legal requirements why the IP-NFT gains value in the end, right? So it is describing the legal implications in the real world. And we are outlining that along a JSON schema. So people who are following that JSON schema will be able to prove to others that this is a valid IP-NFT, and others can read those documents. But what's also very interesting is where the data is stored. And we actually started off storing that on Arweave because it's a persistent blockchain-based storage system. It's very permanent. From an end user's perspective, it's slightly hard to use because you need some kind of Arweave wallet to really interact with that if you want to do it permissionlessly. And it's great. So we actually wanted to stick with that, but we all have a background in IPFS and protocol labs. Protocol labs is even very good friends with Molecule. And actually, it doesn't really matter to end users if it's stored on Arweave, on IPFS, on any other storage system. And on IPFS, things are slightly simpler, and it's of course completely non-economical, right? So you don't have to bring any money along to store something in IPFS, whereas it's not permanent then. But what we are using right now is Web3 storage, which is a sub-protocol, or it's actually a product of Protocol Labs that allows you to store things in IPFS and even get Filecoin mining deals. So what our frontend is doing, it's uploading the metadata that people assemble on our meeting frontend, and then it's storing that metadata JSON structure on IPFS using Web3 storage. In the background, all this content is automatically pinned by Web3 storage, and this means it's actually persisted quite securely on Protocol Apps side. But at the same time, they're also dealing, or they're creating a Filecoin deal. And if this one is settled, you can actually guarantee that the data is persistent for a certain amount of time, usually 30 years or something. And this is why, if you're using those convenience protocols like Web3 storage, you can be pretty sure that everything is as persistent as it's on Arweave, and we didn't see the real need to use Arweave. But just one thing, it should be up to the IP-NFT user on where data is stored. So we are not really forcing anybody to store something on IPFS. If you want to craft an IP-NFT and you think that Arweave is the better permanent solution for you, you can just do that. Our frontend is supporting IPFS and Arweave links as well, if you have the right gateway. And for all the tech savvy among you, using Arweave directly, as you might know, is also not that simple because even the latency between putting data into Arweave and getting it out can take quite a while. So we as Molecule team use Bundler to get around that, which is an absolutely awesome tool to very quickly upload or persist data on Arweave and get it out right in the same second again. And it also allows users to pay for persistent storage in any kind of ERC20 token. And this is actually something that we might consider bringing back to our frontend. This is actually not really usable for end users, at least not for those who are not really into Web3, because you have to bring along, I don't know, DAI or USDC or something. But if you do that, you can actually store something on Arweave using this ERC20 token, which is super brilliant. It's absolutely permissionless if you do that, and you're not relying on Web3 storage, however it's called. This is why it might make sense to bring it back, but at the moment we're definitely just using we're pretty plain IPFS actually in our frontend.
Stefan, do you want to talk a little bit about what kind of separates? So if IPFS is, the best solution out there for decentralized storage, understanding, not necessarily the difference between IPFS and Arweave, but the difference between IPFS and your cloud storage provider here, Google Cloud, AWS, Azure, like what separates right now in terms of upload and download times, cost, reliability, all these different parameters you would care about as a developer. What separates IPFS from these Web 2 cloud storage providers?
First of all, I think this is a big misunderstanding for many people who are pretty new to that space. IPFS is not really a storage protocol. The acronym resolves to interplanetary file system. It feels like a file system, but it's not really persisting anything. IPFS is actually just a distribution protocol that allows people to exchange data with each other. So somebody, for example, Heinrich is announcing data on his machine, and he sends over some kind of, let's call it a hash value, which is not exactly a content hash, but it looks like one. And he sends that hash value to me, and my computer is connecting to the IPFS peers, and they will try to find a path between my computer and his computer and access the binary data that he was uploading, in a sense. It's not really uploading, it's publishing, in a sense. And this makes IPFS itself not really a permanent network. It's just distribution network, right? And if you compare that to S3 or to other cloud providers or cloud storage providers, what they're offering you some kind of guaranteed persistence, right? If you pay money to AWS, they are more or less guaranteeing that your content is there. The content gets a unique URL, you can get it from there, you have some access controls or something. But the guarantees are, of course, they only go that far as AWS is still alive. And I think AWS is not gonna go down anytime soon, I guess. But of course, you're paying Jeff Bezos and his crew to store data somewhere. This is not really decentralized, right? It's Amazon owns your data in a sense. With IPFS, you get your data back a little bit because it's actually stored on your machine. Now you have the problem, how do you have this data forever? And then you come up with ideas like Arweave, for example, which are putting blocks in some kind of blockchain, or putting data blocks in some kind of blockchain-related data structure. and they can actually guarantee that some blocks survive long term. So this data is gonna stay available. And I'm not really a deep expert in Arweave. I know my way around Filecoin pretty well. Filecoin is giving another kind of guarantee to users that data is permanent. They are using zero-knowledge proofs and snarks to preformat hard disks on those so-called Filecoin storage miners. And storage miners can actually prove, they can give you a cryptographic proof that they really have stored a certain block of the data you told them to store. And this makes Filecoin, from my perspective, it's really complex under the hood, but from my perspective, Filecoin really solved a major problem, the problem of persistence, the problem of provable persistence in a decentralized way. This is a super great achievement. I don't know if many people are aware of that, but this makes you cannot really compare Filecoin to S3 in a sense, but you can say, if you understood how IPFS is working, you can just close or settle a Filecoin deal with a Filecoin miner, and then you can rest assured by proving cryptographically that your content is stored for a certain amount of time. And this is what S3 from Amazon, for example, or you can use any kind of remote or cloud storage provider. They, of course, guarantee you something in the boundaries of the SLAs. So they say, yeah, we have an uptime of, 99.997% or something. But they cannot guarantee that there's some fire breaking out in their computing center and they're losing the hard disks. And Filecoin can guarantee that by shifting around the permanent content between their peer-to-peer or the Filecoin miners that are connected peer-to-peer. So I wouldn't say that this is really better or better usable or much faster or whatever it is, but we are still very early here, right? So the whole idea of the Filecoin network is to give the same guarantees as S3 or Dropbox or all those providers can give you today, but in a decentralized way. And this is what makes them a perfect choice for a Web3 startup or Web3 protocol like Molecule.
I do have a quick question, and we don't need to spend a ton of time on this, but you did mention ZK proofs. Do you see ZK proofs being applicable to any of the work that occurs in the Molecule ecosystem or the IP-NFT protocol specifically?
Yeah, I don't really. I mean, what zero knowledge proofs are allowing you is proving some kind of statement that you know without telling anybody else what that statement is. And this is always very, oh my God, this is super abstract, right? So for everybody who's not really familiar with this kind of technology, but what you can basically do with that in a KYC perspective, for example, right? So if you, Benji, so maybe we don't know each other, right? And you say, well, I'm a US citizen. And you want, so I'm building a protocol as a German saying, I want that only people from a Western country may use my protocol. Now, zero knowledge proofs, or from a bird's perspective, they allow you to prove to me that you're the citizen of a Western country. I don't even know which one that is, but you can securely cryptographically prove that you are. Of course, this requires you to have somebody creating a claim for you where that actually claims that you are a US citizen. And now the hard part here is deriving that zero knowledge proof above that statement and creating a proof that's provable by another party like me in a non-disclosing way. And what Vitalik and others are actually doing on blockchains, they make those zero knowledge proofs provable on blockchains. And this allows like super interesting use cases because you can actually prove things to smart contracts. And so in the Molecule ecosystem, there could be hard requirements that some people have to prove that they are an accredited investor for certain kind of use cases. So you must imagine if some people want to invest their money into patents on chain, you can imagine if those are real world patents or this is real world, those are real world entities. You cannot just like go the native Web3 way. You have to have some kind of relationship with the real world. But in Web3, you want to protect the privacy a little bit at least. And what you can achieve using zero knowledge proofs or snarks, particularly, you can actually ask them to create a proof over their humanity or over their attribute of being an accredited investor, and proving and presenting that disproof to our smart contract. And that smart contract can only prove one thing. This is an accredited investor. I don't know who he is. I don't know where he comes from, whatever it is. But it can cryptographically prove that this is really an investor we want to trust and, act accordingly, whatever that means. So this is more or less one of our core use cases. And on the other hand, you can actually also craft zero knowledge proofs, for example, to to gain access to certain kind of data. So if people attach data to IP-NFTs, for example, or if they only want certain, let's say, fraction holders of IP-NFTs want to have this data accessible, they can actually ask them to create a zero knowledge proof that just shows that they are a valid investor. Nobody knows how many fractions they have. Nobody knows where they're living. Nobody knows if they ever invested before something, but they are verifiable investors on the protocol, and this is why they might enjoy access to certain kind of data.
Stefan, I'd also love for you, and maybe you as well, Benji, if you've thought about how you guys are using or thinking about content gating specifically with the DAO tools that Molecule is building.
Yeah, I can take that. So, it is rather complicated, especially because of the field we're in, which is biotech. And if you go and look at how, data is protected in the biotech space, outside, the Web3 ecosystem, just in traditional biotechnology fundraising and running pharma companies, it's their most valuable asset, besides patents. So, patents don't derive their value alone. It's really the additional data that comes and supports the value of those patents that, creates this actual valuable data package. And so, more often than not, almost exclusively, what becomes the moat of a pharma company with IP is the data that's attached to that IP as well. And so they guard that, with we call them walled gardens, but, it's the exact opposite of decentralized science. It's valuing privacy over collaboration, to the extreme. And so, we don't necessarily want to jeopardize that, because it's important that you allow people to continue to hold the data in a privacy preserving manner that allows the IP to remain strong and accrue value. And, just purely open sourcing data is not going to accomplish what we want, which is increased collaboration. And so one of the ways we're thinking about, kind of threading this needle in a more sophisticated way than is currently being done is by increasing the frictionlessness of signing NDAs. So kind of like Stefan was talking about with fractionalized IP-NFTs, which we can get into more of, but the idea of having joint ownership over IP rights enables us to distribute patent rights or patent license rights, correct? But what it doesn't necessarily do is say, okay, we can trust this person to not steal data if they get access to it. So it's only one level of gating. Another level of gating is NDAs. And as Stefan was alluding to, you need to actually understand someone's identity and personhood to genuinely sign a non-disclosure agreement or confidentiality agreement. And this is just because, what is an NDA with a wallet? If you have no idea who the person behind it is. And even then, even if you do have the person's identity and their promise to keep information confidential, if someone's halfway across the world where, confidentiality isn't enforced, how are you going to go get them or find them? So, it really is something we're going to have to figure out. I do believe that there's some sort of protocol that we can develop where, all fraction holders or all owners of the IP-NFT can say, oh, this person has the resume, or they have the credentials, or they've proven that they can add value to biotech. And so we're going to give them a data access coming with the addition of an NDA, et cetera. But there is going to need to be several gating layers in order to increase data access. That being said, we are trying to move in that direction, and, hopefully we don't get it wrong. And, we definitely want to miss on the safe side. But at the same time, our goal is to promote decentralized science, to get more people involved in valuable data and extracting value from it for communities. And so we do need to figure out what is the optimal data access protocol for the data that's coming out from IP-NFTs.
Yes, Stefan,
Exactly.
You've looked quite a bit into, or currently using Lit protocol at Molecule. Can you speak maybe a little bit about the role that Lit is playing in the IP-NFT at the moment?
Absolutely. So if you talk about content gating, and this is what we're currently talking here, I mean, many people know that from the usual NFT space, right? So if you have some kind of certain PFP, you might gain access to, I don't know, a music video or something, whatever it is. It's more or less exactly the same question. It's like if you want to decentralize this concept, you have to encrypt content somehow, right? Because otherwise everybody would just be able to access it. And good luck thinking about this one. How do you encrypt data in a decentralized ecosystem, and how do you keep that encryption key safe? This is actually not a trivial question, right? So where does that encryption key live? And LIT protocol has solved this problem using threshold cryptography and MPC, so multi-party computation. What they are building is a network of nodes that allows you to store fractions of any kind of thing, and particularly of encryption keys. So one of the most simple use cases to explain here is that an IP-NFT, as I mentioned before, or the metadata of an IP-NFT points to certain legal documents, and at least one of those documents is encrypted. And it's actually encrypted on the minter's computer. So the one who is minting that IP-NFT is encrypting that PDF document representing the legal document on his machine. And of course, at that point in time, the encryption key lives on his machine, right? So, but it's still only on that minter's box. And what they are doing, they are asking the LIT protocol to encrypt this key and store it. Now, you must imagine this doesn't work like he's sending that key to the LIT protocol. No. He's sending parts of the key to certain nodes in the LIT protocol. So no node at all, no node of them knows the whole key. Those LIT protocol nodes then create a secret on their side, or fragments of secrets. And this is just to create that encrypted symmetric key, how we call it, right? So it's just an encrypted symmetric key that will, once you decrypt that, this will be able to decrypt the content. Now, if you want to decrypt that, you have to prove that you fulfill some kind of condition on chain. And in our case, this is pretty simple. It's actually, do you own the IP-NFT? If you own the IP-NFT and you can prove that you own it, then we are giving you this symmetric encryption key. Now, this is another magic in LIT protocol. All those LIT protocol nodes observe chains. So you can have an access control condition. This is what we also attach to our metadata, and say, okay, everybody who's owning that IP-NFT, which is usually just one party at a time, may get the decrypted symmetric key. And as soon as somebody, maybe the IP-NFT holder, is requesting the LIT protocol to decrypt that encrypted symmetric key that's attached to the metadata, they'll check if their current wallet is actually holding the IP-NFT. If it does, all of the nodes respond with fragments of the private key to the current requesting user, and on their machine, that symmetric key is reassembled, and they can decrypt the content. Those are actually both the larger building blocks of LIT protocol that we are using. There's much more to evaluate at LIT protocol. They can do many more interesting things with that. For example, keeping private keys or contract controlled, how's it called? NFT controlled private keys, so you can actually control, or you can actually issue or sign chain transactions using NFTs that you own, which is a super awesome idea. We are actually not using this one, but LIT allows us, in a nutshell, to store secrets safely in a decentralized way without disclosing this key to anybody but the parties who are involved.
It really sounds like dark magic, honestly. And the fact that you can get the necessary decryption key from, a certain percentage of the nodes, just like it almost makes no sense. Like how is that from a mathematical perspective? It's incredibly complex. Like I still don't understand it, and just many things, just take the developer's word for it. But it really is incredible.
I still think at the core they are using very well-known encryption primitives that have been developed during the last 20 years. So this is not really magic. What makes them, if you now start thinking, okay, but at some point in time they have to, reassemble the key somehow. How are they storing that? And what they're actually using is SGX or Intel SGX extensions on their servers. So all the computation that's needed to create those key fragments is executed in secure memory enclaves, which means, nobody, I don't know how advanced the NSA is today, but But it's very, very hard to break into those SGX enclaves. This is like secure computing. And this is what they're offering as a service in a sense, right? It's an amazing protocol, I would say, and it's solving so many secret-keeping problems in Web3 space that I would definitely urge anybody who's thinking about that kind of stuff to at least read through their docs, because they're really solving a major problem here.
Talking maybe a bit about the front end and the technology behind the front end, and what kind of tech you guys are using to build that, and from a user perspective, like what kind of wallets would a user need, and which wallets do you support at the moment?
So everybody, I guess everybody who's using Ethereum related blockchain technology will know the name MetaMask, right? Mm-hmm. Everybody knows that there is a MetaMask wallet that's a browser extension. You can use that to create private keys derived from a seed phrase, and so on and so on. You don't really have to understand the details. But after like 6 years of using MetaMask, we all know that using MetaMask is more or less a pain. And this is not exactly MetaMask's fault, because MetaMask always has been, well, I would say it's a tool that's supposed to be used by developers, but not by the average John Doe, right? It's cool. It's already making things pretty simple, but well, there's of course a little break in onboarding MetaMask, getting your first ETH on it, swapping, I don't know, USD, US dollars into an Ethereum currency. Oh my God, you have to explain so many things, right? And this is why one of our upcoming tasks, like this is not the first task we're currently working on, but we're definitely going into that. We also must, as Molecule Protocol, we also must make our frontend applications, for example, for IP-NFT minters, for the fractionalizers, for all the researchers, for our DAOs, we have to make it as accessible as possible to people who are not that deep into Web3. I mean, of course, Molecule is a Web3 company, so right, we more or less can expect that our users more or less know what a Web3 wallet is. But actually, if you think about the whole ecosystem around the research DAOs, for example, I don't know, Athena DAO, I cannot expect that every user or every member of Athena DAO really knows very deeply of how MetaMask is working. And this is why we are definitely going to integrate other kind of wallet options, even wallet options that use federated logins, like login with Apple, not really Facebook, maybe Google or some other login providers, to enable a much more fluid user interface. And of course, we're not building this on our own. So there are other solution providers, very simple ones like Web3 Auth. They're pretty generic in building federated wallet logins using so-called MPC technology, multi-party computing again. So even this stuff is rather secure, because nobody has this private key that's derived from that wallet login. It's actually always split in 3 parts. One part is owned by the protocol, one part is owned by the provider, like Web3 Auth, and one part is owned by the owner. If any of us goes down or loses their part of the key, the other both can reconstruct a new private key to access the data. This is how they mostly work, which is also awesome technology. But from Web3 native perspectives, this is maybe not exactly the technology that's going to be the breakthrough. It's more or less a bridge. Because what also Vitalik is telling all the time right now, and what's the next hot stuff is account abstracted contract wallets. So if any one of you ever used multi-sig like Gnosis, this is already the starting point of it. It's more like you prove to a contract that you own, or that you are allowed to access it as a wallet. And this contract is actually your account. So you're not interacting directly with the chain anymore. So you don't have to store a private key. You only have to be able to create a proof to a contract that it's the right you. And this contract is going to be your wallet. Everything that's happening on chain is going to be issued, or it's going to be originated from that contract that you control. And the good thing about that thing is now that you can actually very easily rotate access keys. So imagine if you are a MetaMask user and you lose access to your seed phrase, you lose access to everything. If you lose your seed phrase to somebody else, they have access to everything that you own. And the only remedy to that is you must be able to rotate your credentials, right? So you have to change your password in a sense. This is absolutely not possible in MetaMask. So if you do that, you have to transfer all the stuff you own in MetaMask to some other wallet you create. But with contract-owned wallets, you don't need to do that. You only have to tell the contract that you're rotating your keys now, and now you have a new password to the contract. And the usability implications of contract-based accounts or account abstractions, they are manifold. There are so many implications with this approach of account management that we absolutely cannot see where this is leading towards, but this is definitely the future. So I said the next step we're taking is definitely making logins or Web3 interactions much simpler for our users by integrating this kind of bridge technology, federated wallet providers, like Web3 or Stories, however they are called. But on the long run, we're definitely also going to support contract wallets as first-class citizens in the Molecule protocol.
Yeah, and I think it's often when we're building protocols or talking about potential user experience to be in our heads, they'll just make a MetaMask wallet and save their seed phrase and sign with their private key and load it up with ETH for gas. And I think we just kind of overestimate people's willingness to go through all of these steps. When people use our applications, we want it to feel like they're using any other Web2 app, and abstract away as much of the back-end rails as possible and the fact that it's on crypto. And so, would just love to, go into a little bit more depth about the importance of account abstraction, because kind of like you mentioned, there's no ability to recover your seed phrase if you lose it. And that's just anti-practical. It's just not practical for what people are used to and what they're comfortable with. And so to be able to, gate signing transactions on chain with logins to just your typical Google, Discord, Apple logins is super powerful, because you can recover those passwords if you lose them. And I think another piece that is going to increase adoption to Web3 and Molecules protocol specifically is on-ramping. So basically the gate between the fiat world and people's bank accounts and their on-chain wallets is, it's just another point of friction. And, it's very dependent on what country you're in, which is the best provider to, help you onboard crypto. But that being said, I mean, anyone who's done it knows it's like a multi-week process to go from dollars in the bank account to USDC or ETH on your wallet. And so the ability to decrease the friction of that process and just have, pay with your credit card and immediately have USDC in your wallet we're still a long way from there, but there are some really cool projects, one of which being Sardine, that is kind of innovating here. And ultimately, the most important number is what the take rate is. So for every $100 you want to put in crypto, what % fee do each of these services take? And making sure that, we're constantly integrating with providers that have the lowest number possible is where we like to play. But on the account abstraction side, one piece where, there seem to be different design decisions is between Web3 auth and Sequence. So Sequence's account abstraction, they require you to sign a transaction on chain, which does cost gas because the record has to be on chain, for you to go deploy a wallet with your Google or Web2 login, basically. But what's interesting is they're covering gas for layer 2 chains. And so I think this becomes another question of, there is no clear winner in the layer 2 space. I think if you go on and look at on-chain metrics, a lot of them have adoption. But ultimately, if we want to build a DeSci ecosystem on layer 2s, we all kind of have to agree to one. And, getting people to make decisions is always difficult, especially because everyone has positions in different tokens. So, I guess, how do you think about layer 2s and, which is your favorite, just selfishly? And, do you see us moving into a layer 2 to kind of subsidize some of the gas costs and prevent users from paying them?
Well, you can actually subsidize gas costs also on mainnet, but then actually we are getting poor. This is not really rocket science. I think OpenZappel installed the gas station network in 2020 or so. So this is very well understood, but it's not that simple. But I just wanted to get back to one point you just mentioned. This is actually, I think everybody more or less would be willing to, create a seed phrase and a private key, whatever, in a MetaMask. This is what you usually can explain to people. This is what they actually can do. What's really hard is they have to pay gas on Ethereum. This is exactly where the user experience breaks. But unfortunately, gas is, you need it. Otherwise, You cannot deal with chain congestion. This is why gas is absolutely mandatory. And as said, you as Molecule Protocol, I think you would not do this on mainnet because this becomes very expensive. And this is exactly why many people just move on to L2s. Now, for all the listeners that don't really know what an L2 is, this is actually this is Ethereum's approach in solving scalability. It's more or less wrapping up new blockchains that somehow are anchored in on a main blockchain, and in that case, obviously, Ethereum mainnet. And the most prominent players of them are obviously Polygon. There's Gnosis Chain, there's Arbitrum, there's Optimism, there are ZK rollups coming up, so-called. For example, ZK Sync is just rolling out, right? There's Darknet, there's Mina Protocol, and so on and so on. And they come with certain trade-offs in potentially security, and I don't know, nobody's stealing your keys here, right? But it's potentially they could maybe break down because they don't have as many nodes as Ethereum has. This never happened, and usually this will never happen. But every time you move onto an L2, you're definitely making a trade-off for security of where you store your data. And this is why this is exactly the right question. So which L2 are you going to use? Because you must make sure that this is going to be around in the next 10 years. And it's not losing your data. It's not like dropping security. It's not like, I don't know, nobody can change the data anymore. Those are all the guarantees that you got from Ethereum mainnet. Those are not really guarantees on those chains because they haven't reached the scale as Ethereum did. But still, you can consider them pretty safe because they all come with their own safety measures. You might lose a little bit on decentralization. But just to answer your question, so favorites. I mean, I don't really have a favorite. I see some of those chains or of those L2 networks coming up recently, and they look very, very promising. And my personal favorite, just to name one, is Optimism, because Optimism also is pretty deeply involved in public goods funding. They also consider themselves a public good, and they want to drive decentralization on scale in the Ethereum ecosystem. This is why I personally like the Optimism approach very much. But this is not really a technical thing. This is more like a personal, I think those are cool guys thing. I also love the Arbitrum people. If you read the Arbitrum documentation with Arbitrum Nova and Nitro, they really showed that they are ready for prime time. They have extremely high scaling blockchain or L2 solutions that derive safety and security from Ethereum mainnet. This is awesome technology. And just to close this, I definitely think that Molecule can profit from the scalability and from the gas efficiency of those protocols for sure. I think IP-NFTs always will reside on mainnet because they're representing a major value. This could be billions of dollars that this one IP-NFT is worth. But the whole fractionalization stuff, the content gating for certain peer groups or something, this actually is definitely a good example of what could be factored out to an L2 network.
Awesome. Yeah, like I certainly am not an expert, but I wouldn't feel comfortable in putting hundreds of thousands of dollars on layer 2s as of yet. So yeah, sticking to the security of Ethereum because I know it's going to be around.
Exactly. But you can be pretty safe. Particularly, I mean, getting stuff out from an optimistic L2 still takes up until a week.
Wow.
It depends, right? So it always depends on how this whole thing is built, which is a major trade-off, of course. So trading stuff on the kind of that kind of chain, you lose a lot of usability if you really do that, and if you want to get in and out. If you just want to trade, you have to find an L2 that has some kind of liquidity fundamentals. So if there's lots of money already on it, a Uniswap works as good on Optimism as it works on mainnet, actually. And this is where it's actually very interesting, like doing your swaps or your trading on L2 and bridge back from time to time, maybe your proceeds if you do any.
Stefan, maybe a burning question from our community would be our open source strategy. So how and when they can start building on this, and or put differently, when SDK?
When SDK? Exactly. So our contracts are open source, so you can see them on our GitHub organization, which is called Molecule Protocol, github.com/molecule protocol. It's surprisingly not that much code because IP-NFTs aren't like super magic technology, right? It's more or less just an NFT with the whole magic going on in the metadata actually. So this is nothing that will blow your mind if you look into it, but all the stuff that's upcoming is going to be developed inside that repository as well. So it's called the IP-NFT repository. All the contracts we're currently building towards the ecosystem are going to reside on that one. What we haven't what we haven't open sourced so far, as said, at least not in code, is the metadata schema description, which we currently built in a TypeScript and Zod. This is residing in our Frontend repository, and there's a reason why this is not open sourced, because the code is still a little bit preliminary. I think we're pretty good coders, but we have to fine-tune a little bit. Once we're done with our, now this is a little spoiler alert, once we're finished with our V3 release, which is upcoming in the next 2 to 3 weeks, we're gonna open source this one as well. And then we have to restructure it a little bit, because now we have quite a bit of stuff living in that so-called Frontend repository. And for all the developers among you who want really to just have an SDK that they can use to, I don't know, validate metadata they want to put into IP-NFTs, or maybe just interact with the lit protocol without really worrying about lit protocol, this is something we're gonna factor out of that repository and bring towards an NPM package that's gonna be installable by all your developers. So in the end, you will definitely be able just to say, show me all the IP-NFTs of this address, show me all the IP-NFTs of the currently logged in user, show me the history of those, ungate the content please, here's an auth stick or something. This is what you will be able to do using a Molecule's SDK without really having to worry that much about Web3 technology. But actually, all the stuff that you need if you want to interact with IP-NFTs already there. As said, everything is verified and open sourced from the contract perspective, so you can just start building on it. You can use IP-NFTs as a building block for your own protocol if you want. You can use them as a gating mechanism to gate your own data or your own, encrypted content if you want so. You don't have to ask us for doing so. You can just start it. But if you are keen on writing like stuff on top, or maybe writing DAO dashboards or tools for Gnosis safe wallets that interact with IP-NFTs in a certain kind of way, you should maybe wait a little bit until we release our front-end code, so you can see how we are actually building things.
Stefan, Benji, thank you so much for allowing me to pick your brain. And to our audience, we hope you enjoyed it and that the podcast provided some insight into the next era of intellectual property and what IP-NFTs can do, and everything that's planned in Molecule and the IP-NFT to come. So thank you for tuning in. We look forward to sharing more with all of you soon. Thanks guys.
We love you all too, Heinrich. See you.
Ciao.
Thank you.
Thanks, Hunter.